Hey guys, let me know if you have any questions or if you need any help with anything or any clarification at all. So yeah, just let me know if you guys have any questions or anything. Oh, I'm pretty good. How about you, Santino? Doing pretty good though. Just trying to stay productive. Hopefully you're doing pretty well too. Yeah, let me know if you guys need any help with anything or if you want to go over any homework problems or anything like that. Oh yeah, just send me a message later to remind me, John, but I can give you the your password and username if that's what you're talking about. But yeah, the website is just explorelearning.com. Um, but yeah, I can get you your password and username if you need that still. Yeah, let me know if you guys have any questions about anything. um, and then I'll post the study guide solutions Thursday, probably Thursday morning. Oh, okay, cool. Yeah, I can get you that for sure. And yeah, for the gizmo thing, you only have to do really just 3 pages. The first page and one of the 3 activities. If you want to do pages, you can get extra points though. So it's up to you guys. Yeah, I believe that one's due Friday. Yeah, that one should be due Friday. So, just to kind of remind you guys, um, the test is going to be on Canvas this Friday, and it goes all the way back to intermolecular forces. Um, Plus this stuff on gas laws. So let me show you guys. Graham's law. So yeah, like the first packet of notes was really just intermolecular forces and types of solids, which we already took a quiz on. Actually, that was a quiz like I think that Thursday, the last day I saw you guys, really. And the next day was the Friday that I wasn't there, and that was the last day you guys were in class. So yeah, we had a quiz on this stuff, intermolecular forces and types of solids. So that'll be on the test for sure. Plus all the gas laws. So I mean, I guess half of it might be, maybe less than half, like a third of it might be multiple choice, and then there's some that you have to kind of work out in steps, like the gas law problems. You have to do some math. Um, yeah, so that'll be on Friday though. I decided, like I said before, to make it times, like give you guys a time limit, just to kind of make it a little more easygoing, so you can go at your own pace. Yeah, let me know if you guys want to review anything at all. I'm trying to get my notes ready for the week after spring break, so those will be up and ready pretty soon. Excuse me. Yeah, so let me know if you guys want to go over any problems or anything like that. I know some people are interested in seeing if I can do a Zoom live stream chat instead, but it looks like the district doesn't want us to use Zoom. They want us to try to avoid that media outlet, I guess. So if anyone's interested, maybe I'll check out the Canvas live stream chat tomorrow. Because I know on Canvas you guys can also like verbally say things back to me and stuff too. It's not just all typing. But yeah, I'm not sure how much we'll get. We don't usually get a lot of people here on the live stream, so we'll see. So I just don't know if you guys have any questions or anything. Yeah, I'm also in the process of uploading a lot of notes for the unit we're gonna get to after spring break, so they're probably private right now, but I'll make them accessible once we get there. Yeah, next week's spring break, so we'll have a break from doing any work or anything like that, unless you guys want to catch up on some work if you still have to do some stuff. But yeah, let me know if you guys have any questions or anything. We just have the study guide today, and it's pretty much all we're going to focus on this week, just to kind of take it easy and just give you guys some time to review, and the test will be Friday. If I find any other like nice resources, though, I'll definitely send them your way through Canvas. Number 3 on ideal gas stoichiometry worksheets. Yeah, let's take a look at that one. So number 3. I might actually have that already worked out over here. Okay, yeah, I have that one right here. That's the one that has photosynthesis on it. So for that one, let's take a look. Yes, I posted that one online as well. But basically, with these questions, it's basically just like a stoichiometry problem, pretty much. There are shorter ones where it's a stoichiometry problem, but you're typically just gonna go from liters of one substance, which is a gas, to liters of another gas. That's not the case for number 3 here, though, because in number 3 we were given grams of glucose, which is a solid. It's not even gas, and we're trying to go from grams of glucose to liters of CO2, right? So here, I'll just go through it step by step, though. Right, so let me just write this out real quick. So 6 moles of CO2 plus 6 moles of water give us 1 mole of glucose and 6 moles of oxygen. So grams, moles, liters, particles. All right, so yeah, we were given grams of glucose. All right, so C6H12O6. I'll show you what I'm writing in just a second. And we're trying to get to liters of CO2. Right, so it's pretty much like, that's kind of hard to see a little bit. Yeah, so the chemical equation's up there. It was just too long for me to fit it all on the top. So you have the reactants on the top, the products on the bottom, right? The arrows over there. And so our given was grams of glucose, trying to get to liters of CO2. So it's just like a typical stoichiometry problem, pretty much. You're starting with grams of glucose going to liters of CO2. So our given was 4.5 grams, right? It's 4.5 grams. In fact, it might be easier if I just show you on here. I worked it out last week. So yeah, so our given was 4.5 grams, right? And so we're trying to go from grams of glucose to liters of CO2. So it's really just like a typical stoichiometry problem. We're going through 3 doorways, right? So we have 3 fractions here. The first doorway is just going from grams to moles of glucose. So you have to divide by glucose's molar mass, which is 180. And then we're going from moles of glucose to moles of CO2. So we choose the coefficients, right? And then after that, we're going from moles of CO2 to liters of CO2. So 1 mole on the bottom and 22.4 liters on top. Again, that 22.4, that's the number that we usually always see in the room here. So it's the number that's usually written in liters. So yeah, it's just a typical stoichiometry problem. There are shorter types of, let me see if I can give you an example of a shorter one if you want to see one. But let me know if you have any questions about this. So this is like just a typical stoichiometry problem. There are shorter gas stoichiometry problems where you're just going from liters of your given to liters of whatever you're trying to find. And when that's the case, you just use the coefficients, but not as a mole ratio, as a volume ratio. Instead, it's the same idea. But instead of moles over moles, it's liters over liters. That's not the case for this one, though. This one's just like a pretty traditional standard stoichiometry problem. All right. Yeah, let me know if you have any questions about that one. It's also posted on Canvas too. So this should be, it's like an announcement in Canvas though. It's not really, I should probably just put it in its own little block, maybe just homework solutions or something, just to make it easier to find. Yeah, so this is just like a typical stoichiometry problem. Let me know if you have any questions about it still though, John. But other than that, there are shorter cases where I can give you an example. Let's say we're trying to synthesize. I'll just go with water, I suppose. So 2 moles of H2 gas plus 1 mole of oxygen gas goes to 2 moles of water vapor. So they're all gases, right? So in this case, instead, let's say I have 0.25 liters of oxygen, and I want to figure out how much liters of water are going to be produced. So you have a question. Is the STP? Exactly, yeah. Oh, yeah, you don't really need to use it there because they were asking for just the volume of CO2. Yeah, you don't really need to do anything there. What you could have done, there's more than one way to do these things. You could have basically tried to go from grams of glucose. So it's extra information really, but you could have solved it another way with that information, which would have been going from grams of glucose to just moles of CO2 right there. So you would stop at that point. You wouldn't have that extra one. You'd stop there. And that would give you moles of CO2. And then you would plug that into the ideal gas law equation. You'd plug it into PV equals nRT. And your pressure would be 1 atmosphere, and your temperature would be 273 Kelvin, and you would use the corresponding R value that works for atmospheres, 0.0821. And then you should end up with the same volume. You should get the same answer here. But you don't have to use those values. That's just if you want to solve it that way, or you can just treat it like a normal stoichiometry problem here and just do it this way. So yeah, it's kind of like extra information, really. But there's like more than one way to solve it, though. But for something like this could be a shorter gas stoichiometry problem. This is just the synthesis of water. So we have 2 moles of hydrogen gas, 1 mole of oxygen gas, making 2 moles of water vapor. And so if you're given is like a 1/4 liter of oxygen and says how many liters of water will you form, this is like the shortest possible case of a gas stoichiometry problem. So you're given is 0.25 liters of oxygen. And typically, if I'm trying to go from liters of one thing to liters of another thing, I would typically start in liters, go up to moles, go over here to those moles, and go down to those liters, like an upside down U sort of shape. But because your 22.4s are just going to cancel when you do that, it's really just the mole ratio that matters. So you can bypass all that. And instead, and this is what the notes were talking about, instead of using a mole ratio, you use the coefficients as a volume ratio. It's the exact same thing, but it's just volume instead of moles. So this is like a short case of a gas stoichiometry problem, right? So we're going from liters of oxygen to liters of water. So I have liters of H2O over liters of oxygen, and I just use the coefficients here, just like the mole ratio, but we're calling this the volume ratio instead. So it would just be 2/1, right? So in that case, it would just be 1/2 liter of water. All right, just double checking. Yeah, 1/2 liter of water. So this is like the shortest possible gas stoichiometry problem. Again, you could do moles up there, 1 mole down here, and 22.4 liters, 1 mole. So here, let me try and divide it. So it's kind of crammed. But on the bottom here, this is like the other traditional stoichiometry problem or method you could use. So it's the exact same question, going from a 1/4 liter of oxygen to liters of water vapor. How many liters of water vapor will that give us? And notice if you do it the traditional way, going from liters to moles to liters, the 22.4 is going to cancel. It doesn't make a difference mathematically. So it's really just this ratio here in the middle, which is what we call the mole ratio in the last unit, the stoichiometry unit. But in this case, we just call it the volume ratio instead because, yeah, these 22.4s cancel out. So that's why we just do it like that up here. That's the quickest possible gas stoichiometry problem you'd have. What you'd probably see on the test is a lot more like the gas stoichiometry problem on the study guide, which has you try to calculate moles of a substance And once you get those moles, then you have to plug that into the ideal gas law problem, kind of like what you're saying there with the standard temperature and pressure. Yeah, so let me know if you have any other questions though. Let's see. So I did it that way. Let me see if I can show you the other way. Oh yeah, no problem. Just let me know if you guys have any other questions or anything. So let me see if I can show you the other way. Because yeah, it's sort of like extra information, but you could use those values just to solve it a different way. But you could also just do it the stoichiometric way like I showed you. I mean, either way, you're going to have some sort of stoichiometry. So 0.15 moles of what is this? CO2. And so the volume is nRT over P. So N is 0.15, this is 0.0821, this is 273, and this is 1. So we should get about the same thing, 0.15 times 0.0821 times 273. Yep, we get the exact same answer. So those standard temperature and pressure values, you could have done it like this, where like the way I showed you here, we went all the way to liters of CO2, but if you wanted to, you could have just stopped here and gone to moles of CO2. And by doing that, you get 0.15 moles. I did the same thing up here. I just took off all the units and stuff to make it quicker. So 0.15 moles, and then just use the ideal gas law, and 273 is up there, 1 atmosphere is down there, but you'd still get the same answer. You'd still get 3.36 liters. So if you put that all in the calculator, it's still 3.36 liters. Oh, sorry. So yeah, you could do it more than one way. It's just up to you, really. But yeah, so on the test, there will be a gas stoichiometric problem, kind of like the one on the study guide, though, where first you have to get moles of a substance, and then it's not standard temperature and pressure. They're different temperatures and different pressures, but I'll give them to you guys. And you have to use, the ideal gas law to figure out the volume of that substance. But even then, you could still just use stoichiometry to solve it. So there's more than one way to solve these things, which is kind of nice. Yeah, so let me know if you guys have any questions or anything. If you want to go through any other examples. I know it's maybe only one other person here. Maybe 2 people here, I'm not sure. Yeah, I'll try to do a live stream every day this week, just in case people have questions before the test. Let me know if you guys need any help or anything still. Yeah, so if you guys need any help or anything, if you have any questions about any examples at all, I'll probably stay on for maybe another 10 minutes. It seems like it's pretty dead today. Yeah, I'll probably I'll probably end it for today. It's pretty dead today, but I'll do some more live streams throughout the week, every day, just in case anyone has any questions. But take care if anyone's out there. Hope you have a nice rest of your day.